Okay, so we'd like to do this task 1 to build a min heap with the keys 11, 8, 7, 4, 9, 6, 2 using this top-down method. So the top-down method, yes, let me put this on the screens. The top-down method we just seen, let me just erase these and start from scratch. So how can we do the top-down method? Remember, we start with adding the first one, so let's add this 11. No, brush. Okay, we have 11, then we add 8. We always add the top left most leaf, and then this is a min heap, right? So the minimum should be on the top, so we need to do some kind of swapping up or percolating up. So we just now swap up. Let me just maybe do that in a different way. Let me do it from here, and then we add 8. Then what we need to do is now 8 and 11. Then we add 7, and then we added 7, and we still need to do some kind of swapping, so it becomes 7, 11, and 8. Then we add 4, which is going to be here. So now we need to 7, 4, 11, and we have 8 here, and we still need to swap. So this let me represent this like this, so we need to swap. So we know that we need to swap by doing some kind of this, and we still need to swap, but this time the 7 and the 4, which means now we have 4, 7, 8, and 11. Now we need to add the 9, so we add the 9 here. No need to do anything. We need to add the 6. We add the 6, but we have to do some kind of swapping, so we need to swap these two. So we have 4, 7, 6, 11, 9, 8. And do we need to swap? No, we don't need to swap now. We're fine. And then we add the 2, which is going to be here, and we need to swap the 2 with the 6. So we have 4, 7, 2, 11, 9, 8, and 6. And we still need to swap 4 and 2, which gives us finally 2, 7, 4, 11, 9, 8, 6. Is that okay? And then we have this here that if you inserted 2, 7, 4, 11, 9, 8, 6, after you insert one after the other, insert 11, 7, and then 4, and it just keeps up putting them at their place and then swapping. At the end of the swap you have the result, etc. So we have this as a result of that. So the idea is that we have a set of values and we put them top down every time, and then we swap whenever it's needed. Yes, now let me stop this here. Yeah, I'm looking for this thing here. Stop the video and continue. So we'd like to do the same thing now, but with the bottom-up approach, right? So the bottom-up approach means that we are going to insert everything, and then we are just going to do the swapping later. So let's go to the bottom-up. Let's insert this 11, 8, 7. So we have 11, 8, 7, 4, 9, 6, 2. 4, 9, 6, and 2. Okay, now how are we going to? So the last non-leaf node is the 7. So we start with the 7, and then this is again a min heap, which means all you got to do, try to find the minimum in here. So which is going to be 2, which means this is going to be 2. This is 7. And then we go to the 8. So we're going to check this one now. And from this one, we just found that the 4 is the smallest. So we are going to make this 4 and make this 8. And then, so for the 11, the whole thing, now we're going to compare between 4 and 2. We put 2, 11. Is it the same result that we had?
No, we need still to shift.
But because we should not stop here, we still need to continue when we do that. And this has also some children. We need to also compare this with the children. So we need to swap up again. 6 and 11. And that's what we're going to get. Is it what we got with the other one?
No, different.
So, but the most important part is that we have the 2 on the top. That's the most important one. And then here we have 4 and 6. We have 4 and 7 here. And then it doesn't matter because once we dequeue, we're going to find which one is the smallest and then put them up. And we sort them again. So that's why, I mean, this is better than sorting the whole array, because sorting the whole array is going to take a lot of time, and we don't really need that. We just sort just to find the smallest, and then we put it on the top, and have the each level be organized in a way that it's smaller than the one that is after, and then we just keep moving up. And that's this solution to this. How we can try that? Maybe by just running this again. Can we clear? There's no clear, so let's quit and start probably. Yeah, I meant 5. It stopped already. Okay, and so we start this bottom up. So how many elements? 2, 4, 6, 7. And the elements were 11, 8, 7, 4, 9. 11, 8, 7, 4, 9, 6, 2. And this is going to give us 2, 4, 6, 8, 9, 11, 7. Is that okay? All right.